Okay. So, today we're going to be looking at something called function operations. And composition. This most likely will be review, okay? And in fact, if you were pretty comfortable with what we did yesterday, then today you should be pretty comfortable as well. Okay, which is good news, right? So, let's start with two functions, okay? So let's say we have h of x, actually sorry, no, not h of x, sorry, it's called f of x. Given f of x, I'll say f of x is equal to something simple like 5x just to start out here, and we'll say g of x is another function here, and it's going to be equal to, I don't know, just like x plus 2. So given these things, we're going to find h of x. Okay. And we'll have some different scenarios here. So for our first scenario, we'll say that h of x is simply equal to f of x plus g of x. Well, if h of x is equal to f of x plus g of x, then how do we do that? How do we add f of x plus g of x? What will it end up being? How do you get 6x plus 2? Exactly right. Okay, when you have two functions and you want to add them together, you can just replace the f of x with what it's equal to, right? It's equal to 5x. And then we're going to plus, and we're going to add the g of x, which is just x plus 2. Okay, if you want, you can put like parentheses around there, so they kind of like substituted it in. You know, the parentheses aren't necessary in this case, though, because there's nothing that we need to do anything. You know, there's nothing else to do with those parentheses. We can kind of drop them. We can just combine like terms, like Greg did there. 5x plus x is 6x, and then there's nothing for the 2 to combine with, so we'll just do plus 2. And so that's what h of x would equal. Okay? It's just like adding polynomials, okay? I mean, kind of, it's like a monomial plus a binomial there, right? We added those two polynomials together. Okay. What about like h of x equals, excuse me, let's do f of x minus g of x. Right, so now we want to subtract them. Well, it's just like adding. Right, again, I'm going to replace, though, f of x with what it's equal to, the 5x there. I'll put it in parentheses. And then minus, again, g of x, which is, again, x plus 2. Now, here, parentheses are kind of important, right? Because what does that minus in front of the parentheses have to do? We got to distribute that minus sign to each term here. So it's 5x minus x minus 2. Okay. 5x minus x minus 2. And so that's going to simplify. 5x take away an x is 4x. And there's nothing for the 2 to go with, so it's just 4x minus 2. So watch those parentheses there. We want to make sure we have parentheses in there. All right. Well, h of x could instead be, what about like f of x times g of x? We can actually multiply functions together too, right? Which would look like 5x times x plus 2. How do we multiply this out? distribute again. That's right. 5x times the x, 5x times the 2. So we get 5x squared plus 10x. And again, there's no more like terms combined, so we're done with that. Okay. One more we can look at here with this, and I'll have you guys try some. H of x equals f of x divided by g of x. So what would that look like? Well, f of x again is 5x over x plus 2. We haven't talked yet about how to divide these things. I think we're going to talk about that later, like a later chapter, later section, later unit. Right now, we'll just leave it like that. There's no easy way for us to simplify that from what we know, so we'll just kind of stop there. And believe it or not, you can use long division there to divide those things. You can use long division to divide polynomials. Okay?
What about if it was 6x?
No, unfortunately not, because again, so Greg's question was, what if instead of having a 5x up here, what if we had like 6x over x plus 2? And then like the 6 and the 2 might simplify, right? Unfortunately, they can't, because we don't have this, like, the x is having this 2 being added to it. If it was exactly. If it was 6x over 2x like that, then yes, the 6 and the 2 can simplify, and then the x's can also cancel. If it was 5x plus 2 on top, so if it was like 5x plus 2 over x plus 2, you mean? Well, even that wouldn't quite simplify. But, like, for example, if I had like 10x plus, oh goodness, 20 or something. Yeah, exactly. You would need to have, so I could take a 10 out, be left with x plus 2 over x plus 2, and then the x plus 2's could cancel, because you need to cancel the exact same thing, so x plus 2. But again, we're not too worried about that right now. We'll get to that in a later unit, I think. Okay, so let me have you guys try some here. Okay, so here we'll say given f of x equals 4x to the 1/2 power, okay, and g of x equals negative 9x to the 1/2 power. To the 1/2 power? We'll see. Okay. So for the first one here, I want you to find these. Okay, so find f of x plus g of x. And then number 2, try f of x minus g of x. And then number 3, f of x times g of x. Okay, so try those 3 things there. Okay. And then yeah, well, you know, do your best with them. If you're like, if the 1/2s are throwing you off a little bit, we'll try something. Okay. We'll go over it. Give us a try. If you get stuck or something, let me know. All right, so Jake, what'd you get for number 1 there? Exactly right. Okay, so here we're going to add these two things together. Okay, they're like terms, right? Same variable, same exponent with that variable, and so they're like. We just put them together. So it becomes negative 5 x to the 1/2, and that's the best we can do. Next one, f of x minus g of x, same idea. Except now we're going to subtract minus negative 9x to the 1/2. So of course minus and negative becomes plus positive, and so we can add those together to get 13x to the 1/2. Okay? Now how about number 3? Carlos, were you able to come up with anything for number 3? We multiply. So we can substitute in, right? It's 4x to the 1/2 times okay, so it'll be negative 36, yes. 4 times 9 is negative 36, and then x to the 1/2 times x to the 1/2. It'll be negative 36x, yes, very good, to the 1, x to the 1. Is that what you said, Connor, 2x to the 1? Ah, when we multiply numbers that have the same base, we add their exponents. Okay. What's that again? Yeah, so if you have like x to the 1/2 times x to the 1/2, that's equal to x to the 1. You add them together. If you have x to the 1/2 to the 1/2 power, like you were, then that would be x to the 1/4, Connor. 1/2 to the 1/2, like that. You multiply the exponent.
Do you have to write down the 1?
Oh no, you could just leave it as this if you wanted to, or put the 1. It's up to you, right? Because it's implied there's a 1 there. Okay, so that's the idea. Okay. Now, one other thing I want to show you, right? So that's what I meant by function operations, right? We can just take our functions, add them, subtract them, multiply them, divide them. You know, I could do stuff like, or we could do stuff like 2f of x minus 3g of x, right? Where you just do twice f of x and then subtract 3 times g of x, and, you know, combine like terms that way and stuff too. So all that. There's one other thing though. I want to talk about composition. So let me just put a little line here. Okay. Okay. So you can see it written in a couple different ways. Sometimes you'll see it written this way. F, a little like circle or a little O where like a multiplication symbol might be. What does this mean? It just means f of g of x. So you can see that g is plugged in to the function f. Alternatively, you could see this, g of f of x, which this is g, and then f of x is plugged into that g function. That's called a composition of functions, right? You're composing one function inside of the other. You're coming up, you're plugging one into the other. Okay. Okay. So that's what some of these symbols are going to mean. But what does it actually look like when we do one, right? What actually happens? Well, let's start with some examples here. So let's let f of x, in this case for our example, be equal to 3x minus 8. And let's let g of x equal 2x squared. Okay. And let's find f of g of x. Okay. Well, in order to plug g of x into f, I need to know what is g of x. And what is g of x? 2x squared. So instead of writing this, I can write f of 2x squared. You see, all I did was just replace the g of x with what it's equal to, the 2x squared there. Right? Just like that. The g of x becomes 2x squared. Now it's up to me to evaluate f of 2x squared. Okay? Well, if I look here, I know that f applied to the variable x is 3 times that variable x minus 8. So now if I want to apply f to 2x squared, well, it's going to be 3 times that 2x squared minus 8. So the x gets replaced with 2x squared, right? Here, f of x is 3x minus 8. So f of 2x squared should be 3 times 2x squared minus 8. All right, and we just simplify. What is 3 times 2x squared? 6x squared. And then minus 8. And that's our final answer because we can't simplify it any further. Questions on any of that? I was going to have you guys do this next one, but I think we better do it together just because it's a little bit different. What about g of f of x? So now I've swapped places, right? I'm plugging f into g, and I want to simplify that, right? Before I plugged g into f. I took that 2x squared, we plugged it into f. Now I'm going to take f of x, 3x minus 8, plug that into g. Are we going to get the same answer? What do you think? No? All right, let's find out. Yeah, we will? Okay, well, let's see. So, f of x, right, I'm going to replace that with 3x minus 8. So, instead of g of f of x, I'll say g of 3x minus 8. Okay, again, I just replaced the f of x with what's equal to 3x minus 8. And now I'm going to do g of 3x minus 8. So that 3x minus 8, where does that get plugged into in my g function? Where do I plug that into my g function? It replaces what? Not the 2. The 2 will still be there. The x, yeah, it just plugs in for x. So it's going to be 2 parentheses 3x minus 8 quantity squared. Exactly. It just replaces the x. It substitutes in. Yep. Now, how do we square 3x minus 8? And what does it mean to square that? Not yet. We don't want to distribute it. You can't distribute. Oh, well, we got to take care of exponents first, right? Order of operations, parentheses. So there's nothing in parentheses, and then exponents. So let's do it this way. Right? Isn't that the equivalent? Because when you square something, you multiply it by itself. And now you can see when we multiply this out, we have to use FOIL here, right? So we still have that 2, and it's going to be, let's see here, 3x times 3x is 9x squared. Outer will be minus 24x. Inner will be minus another 24x. And then the last will be a plus 64. And that's be minus 48x when you combine like terms, plus 64. Okay. And now we have to distribute that 2. So we 18x squared minus 96x plus 128. Okay. So it's very interesting. Using the same functions, but a different order. Same functions, just a different order applied to them. we result in very different answers. Okay? Very different answers. Later, we'll talk about things called inverses. And when you compose them like this, both ways, they should simplify down just to x. Okay? We'll talk about that later, inverses. Okay? Inverse is a very special relationship. These two functions are clearly not inverses because they don't simplify down to just x here. They simplify down to some other stuff. But that's the idea there. Now, one other thing I want to talk about here. We can also do things like f of g of 2. We can evaluate functions at a value instead of just like an x. Right? So here we just left it as x and left this as x as well. These, I think, are actually easier than like number 1 and 2. Because, for example, I can just take my time here. I can evaluate g of 2. I can say, okay, well, g of 2, that's equal to 2 times 2 squared, right? I just put the 2 in for the x here. Which is 8. So instead of evaluating f of g of 2, I can instead evaluate f of what? 8, right? Yeah, it's the same thing. So there you go. You just say f of 8. And now to evaluate f of 8, well, that's easy. I can just do 3 times 8 and then minus 8. So that's 3 times 8 is 24. Minus 8 is 16. So when you're evaluating a number, f of g of 2, it's easy to just do the pieces. The inner piece, g of 2, and then f of that answer. Okay? Alternatively here, though, Jordan, do you want to say something? Yeah. Alternatively here, okay, since I had just evaluated f of g of x and I got this, I also could have plugged the 2 into this, right? If f of g of x simplifies to 6x squared minus 8, then to evaluate f of g of 2, I can just put the 2 in here. 2 squared is 4. 4 times 6 is 24. Minus 8 would give us that 16 there as well. So it's, up to you depending on the kind of problem that you have and what you have to do there. All right, let me give you guys one to try here. I want you to evaluate g of 3. All right, so you all try this one here. Just about out of space. Okay, evaluate g of 3. Okay, just evaluate g of 3. Yeah, the same functions we've been using. Yep. Ooh, you're going to need a calculator for this probably. Okay. G of 3. Three digits. Yep. I should have known that too. Square's going to use square again. So it's bigger. Okay. Have we able to come up with an answer for us? Okay, so what did you try so far?
I'm having that trouble getting started.
Okay, so g of 3, right? That's what we want to try and find. I'm going to try and, actually I'll just do it on the board up here, okay? So g of 3. All right. If you look here, right, the kind of innermost piece that we have is this g of 3. What's g? According to our, I know there's a lot of work up there, but what is g? 2x squared. So g of x is 2 times that x squared. So if I want to find g of 3, what should I do? Yeah, so like this, right? So that's what you meant?
Yeah.
Okay. All right, so we simplify that. 3 squared is 9 times 2 is 18. Okay. So far, so good? So we just evaluated g of 3, which means instead of writing g of 3, I can now just write g of what? 18, right? Replace the g of 3 with 18. Well, now I just need to find g of 18, right? I just found g of 3. Now, because I found g of 3 to be 18, I got to find g of 18. So, same thing. Okay. So, 18 squared is 324. Then times 2 should give you 648. Okay, so that's the idea. All right. Question? Yes. Okay. So another option that you guys have here, and maybe well, to evaluate g of 3, you could find g of x first, and then plug in 3. So we could do g of 2x squared, which would be then 2x squared squared. So it's up to you whether that's that or not. Anyway. Okay. So essentially, Patrick is just plugging in the one time and then plugging in again, because g of 3 we're using the same function twice. All right, so let me give you guys your assignment here, because that's all we're going to be covering today, okay? That's it. So you guys get some practice in here. Make sure you're good to go. The practice will be out of the green hardcover book, so you're going to have to go grab one of those in the back. Maybe take a picture with your phone if you need to. If you don't want to have to carry the book. Actually, you'll need to if you got to finish it at home, because I don't want you to take the books home. Okay. So on page 432, I'd like to do 3 through 9 odd. So 3 to 9 on, 13, 15, 21, 32.